Hey guys, this is Philip, and today we're going to talk about the quadratic formula. Before I begin, I just want to notice, well, you're probably noticing that I'm actually showing my face this time. I just thought I'd try something a little different. I'm not really sure how this is going to work, if it's going to be more or less engaging, but I thought I'd try something a little different this time. So let me know what you think. So, here we go. So, what is the quadratic formula exactly? So basically, it's a formula that gives you all of the x-intercepts in a quadratic equation. But it has to be in standard form. So it has to be y equals ax squared plus bx plus c. And so the x-intercepts are just basically whenever the function crosses the x-axis, or y equals 0, the function is equal to 0. So I covered a video on factoring in the past, which also gives you the x-intercepts of a quadratic equation, but the problem with that is it only works in certain situations. Like, it'll only give you the intercepts that are either fractions or integers, which are basically just rational numbers. But if the x-intercept is something like the square root of 2 or the square root of 3 or square root of 5, any kind of radical or any other irrational numbers that don't have a repeating decimal but an infinite decimal, then the factoring does not work. So in that case, you have to use a quadratic formula. And also, some cases, factoring is just inconvenient. Like, it's really difficult to find all the factors, and then it would just be easier to use the quadratic formula. So in a way, you can think of the quadratic formula as a universal way to find all the x-intercepts in a parabola or a quadratic equation, but just make sure the quadratic formula has to be in standard form. If it's not, you can just manipulate it into standard form. And just as a side note, you probably already know this, but as a parabola or quadratic equation can have two intercepts, which means it crosses the x-axis twice, or it could just cross once, or it can not cross it at all. So sometimes you won't get an answer, or no solution, like square root of negative. And there's an easy way to determine that without going through the entire quadratic formula, and I'll let you know how to do that in a little bit. Okay, so now I'm going to cover what the quadratic formula actually is. So the way I learned it, and I still remember it because of this, is actually I learned it through a song. And I'm sure a lot of people have actually learned it through this song, and I'll sing it for you right now. So it goes like, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So the x at the beginning, x equals, is just the x-intercepts. And then the a, b, and c are the same a, b, and c in the standard form equation. So yeah, that's just the formula. And I'm going to go over how you use it on the written part. See you there. Alright, so now that we're past the conceptual phase of the quadratic formula, now we're going to just cover a few examples and do like the algebra. And sorry, my voice sounds a little bit different. I'm recording this section on a different day, and I'm actually a little bit sick. So bear with me. I think it'll be alright. So we have negative 5x squared plus 3x plus 3. And that is our function. So we're going to use a quadratic formula. You can't actually factor this. You can look at my factoring video and try to factor it as best you can, but basically the only factors multiply up to 3 are 1 and 3, and there's no way you're going to be able to get it to add up to 3 multiplied by 3 and get this negative 5. It just doesn't work. So here we go. So we're going to do the quadratic formula, and just remember the song. Man, it's going to sound weird with my slightly messed up sick voice, but hey, I'll try it anyways. So you've got x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So so in this whole like ax squared plus bx plus c, this is negative 5, that's the a, the positive 3 is the b, the positive 3 is the c. So all we have to do is plug it into this formula here, and then we are going to have negative 3. I'm just going to try to switch up the colors a little bit. Actually, I should probably use the red for negative b. So we got negative 3 plus or minus the square root of b squared. So that is 3 squared minus 4, and then a, which is negative 5, and then c, which is 3. Okay, so we're just going to expand this so it looks a little neater, and then it's all over 2 times a, and then a is negative 5. So this plus or minus shows that you will get 2 solutions, assuming this is a positive number here, and sometimes it won't. Sometimes you'll get a negative, and sometimes you'll get a 0, and that's a quick way. This little section here is actually what is called the discriminant, and that is what tells you how many intercepts there will be, and I'll go over that at the end. So for now, we're just going to do this part. So we're going to simplify, so we'll just do what's inside the radical here. So inside here is going to equal to, so you got 3 squared is 9, so you've got 9, and then 4 times 5 is 20, times 3 is 60, since it's negative negative, so 9 plus 60, so it's going to be negative 3 plus or minus the square root of 69 all over negative 10. So that's actually pretty much your answer. So your x-intercepts are equal to, you could just write it like this. Sometimes your teacher or whatever would prefer it if you wrote them separately. So in which case you just do negative 3 plus root 69 over negative 10 and negative 3 minus root 69 over negative 10. And if you plug, this is going to be like, this would be your solution. So you aren't going to be able to factor and get these solutions, because if you were to plug these numbers into your calculator, they're going to be long decimals, irrational numbers. And yeah, so that's basically one example for a basic quadratic equation which you can't factor, and you have to use quadratic formula to find the x-intercepts. So this is another example where, okay, so with the discriminant here, since we got a positive number, we got 2 answers. But just as a quick rule of thumb with the discriminant, so remember that's this little section, or in the general equation, this is this little section. If the number inside evaluates to a positive value, you will get 2 intercepts. If the discriminant evaluates to 0, then you'll get 1 intercept, which means like the vertex, like the bottom of the curve, or the top of the curve. The max or min will be at the will be along the x-axis, so the y value will be 0, whatever at that point. There's only 1 x-intercept. And if it is a negative number, that means there's no solutions, which means there will be 0 intercepts. And we're going to go over an example for each of those. So this next one here, x squared plus 2x plus 1. So we know there's an imaginary constant here, a constant here, and a constant here, right? So you know a is going to be equal to 1, b is going to be equal to 2, and c is going to be equal to positive 1. So we have our numbers here, and then we're going to just do the equation. I'll sing it one more time, make sure it's really in your head so you have it memorized. It'll stay with you for life. Okay, so we have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so now we're just going to plug them in. And some people just use a quadratic formula for like every quadratic equation, which you totally can. Sometimes there's faster ways to do it, but the quadratic formula will work in every situation. So some people just resort to that, which is totally fine. It's up to you. So yeah, we're just going to plug these numbers in. So we've got negative 2 plus or minus the square root of b squared, which is 2 squared, minus 4a, which is 1, and then c, which is also 1. So there we go, and then it's all over 2 times a. A is going to equal to 1. So then we can simplify this, but if you notice, inside here, 2 squared is 4, and this 4 times 1 is also 4, so 4 minus 4 is 0. So then you end up with just negative 2 plus 0 over 2, and you have negative 2 minus 0 over 2, and those end up being the same answer. Plus or minus 0, it doesn't matter. It's both negative 2 over 2, negative 2 over 2, and they both evaluate to the there's only one x-intercept, and there aren't two, and the x-intercept is equal to negative 1. So that'd be the answer. And also, if you're clever enough to realize, there's so many ways to figure out solutions, but if you notice, you can actually factor this, and it's a perfect square. It's x plus 1 times x plus 1, which will also just be written as x plus 1 squared. And if you set that equal to 0, when the y value is equal to 0, the function is equal to 0, x is going to also equal negative 1. But yeah, so the quadratic formula will work in every situation. And in this situation, when the discriminant is equal to 0, you only have one x-intercept. So you just quickly take a quick look, and you'll see that. And this is one last example in which the discriminant is going to equal a negative number. So since we know that you can't take the square root of a negative number, well, you can, but you're going to get an imaginary number. There is no real number that you'll get from a square root of a negative number, so you won't get an intercept. So this is a perfect example, and you also cannot factor this, by the way, because there are no solutions. So we're just going to do that really quick. So we've got x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so we're just gonna, since they're all equal to 1, the a is equal to 1, the b is equal to 1, the c is equal to 1, we're just gonna write this out really quick. And if you notice, we've got the square root of basically 1 minus 4, which is the square root of negative 3, which is basically root 3i. That's an imaginary number. So basically, that makes this whole thing be no solution. There's no solution to this equation. There is no x-intercept. And if you want to see what that looks like, I can graph it really quick. Yeah, this is y equals x squared plus 1. If you see, this is the y axis, this is the x-axis, and it starts to go to its minimum, and then it comes right back up. It never actually crosses this axis. And if it were to, for equations that do, if it's upside down, or if it's going upward like a U-shape, it can cross it twice, or it can just right at the very tip of it touch it once, and then come right back up again. So yeah, those are the 3 situations in which it would. So yeah, that's pretty much everything. Yeah, just remember, discriminant is really helpful if you're gonna have any solutions or not. So yeah, that's it. I guess you're gonna see my face again in just 1 minute. Okay, so I hope you guys enjoyed this video. Hopefully it was helpful. I did format it very differently than I have in the past few. It's still a new channel, still trying to figure things out. This video did take a lot more effort and did take a lot more editing, but I think it is better this way. I don't know, I think I'm kind of like this way a little better. It does take more work, but I do think it's worth it. As long as it's helpful. If it is, let me know. And yeah, I'll keep it up. If you're new, feel free to subscribe, and if you like the video, feel free to like, comment, tell me what you think of this video, and I'll see you guys next time. Peace out.